Hello students, today we are going to discuss the combinations. In the previous video we have discussed what is permutation. Now today we are going to discuss combinations. You already know what is permutation. Permutation is the arrangements of some objects, and in the combination is the selection of the objects from the given objects. Means combination is selection. This is the keyword you have to. This is the meaning of combination is selection. In combination there are some objects and we have to select some or all objects from that objects. Then the number of which are discussed here. So consider an example. Suppose that there are three objects A, B, C, and we have to find out the number of combinations. Means we have to select two objects at a time from these three objects. Combinations. Number of combinations, sorry, this is number of combinations. When two objects, when one object is taken at a time. When we have to take one object at a time, then the selection is either of A or of B or of C. So there are three selections in which first we can select any of one of them. We can select A or B or C. So there are only three selections. Now we have to find when two objects are taken at a time. Two objects are taken at a time. Then the selection is either of A and B, or of B and C, or of A and C. There are three selections. We can also write AB as BA, but AB and BA both have different arrangements, and the selection is same because in the selection A and B are included in both. In this selection or in this selection, these two selections are same, so we write it at once. Now if three objects are taken at a time, three objects are taken at a time, then what is selection? The number of selections is only one because A, B, C, all the three are taken at a time. So this is the selection. So there are three selections when one object is taken at a time. There are three selections when two objects are taken at a time, and there is only one selection when three objects are taken at a time. Now we are going to define the combination, and we will give a formula for calculating the number of combinations or number of selections. So combination is number of combinations of n different objects number of combinations of n different objects when r objects are taken at a time, r objects are taken at a time, is denoted by NCR and is given by NCR equal to factorial n upon factorial n minus r into factorial r, where r is less or equal to n but greater than 0. This is the definition for combination. Now we find some results from this formula. If we calculate the value of NC0, then what is this? Factorial n by factorial n minus 0 into factorial 0. And all of you know that value of factorial 0 is taken as 1. So this becomes factorial n by factorial n. So this is equal to 1. Value of NC1, this is written as factorial n upon factorial n minus 1 into factorial 1. Then we can extend factorial n to the value n minus 1. Then we get n into factorial n minus 1 divided by factorial n minus 1. This is cancelled out with this. We get n. In a similar manner, NC2 can be evaluated factorial n by factorial n minus 2 factorial 2. Now factorial n can be expanded up to value and factorial n minus 3. We get n minus 1 into factorial n minus 2 divided by factorial n minus 2 into 2. This is cancelled out with this. We get n minus 1 by 2. This is the value of NC2. If we calculate the value of NCn, then this is equal to factorial n by factorial n minus n into factorial n. This is cancelled out with this. We get 1 upon factorial 0, and this is 1. NCn equal to 1. These are some results on this formula. Now we are going to discuss some theorems on combinations. The relation between NPR and NCR. We know that NPR equal to factorial n by factorial n minus r. We can also write it as factorial n by factorial n minus r into factorial r multiplied with factorial r. We multiply both numerator and denominator by factorial r, and this is value of NCR into factorial r. Thus NPR equal to factorial r into NCR. This is the relation between NCR and NPR. It is clear, students? Now we are going to discuss some theorems. Theorem 1. NCR equal to NCM minus R. The value of both of these are same, because we can take RHS, then this can be written as factorial n by factorial n minus R into factorial n minus R. You already know that NCR, the formula from NCR, we can write it as factorial n by, this is cancelled out with this, we get factorial R into factorial n minus R, and this can also be written as factorial n minus R into factorial R, and this is the value of NCR. This is LHS. So this is the proof of this theorem. Now next theorem, theorem number 2. In this theorem, if NCA equal to NCB, this implies either A equal to B or A plus B equal to N. So students, let us try to prove this. Here NCA equal to NCB, then we can compare both of these. We can take A equal to B by comparison. A equal to B by comparison. Also, we can also write NCA equal to NCB. This implies NCA equal to NC n minus B from the previous theorem 1. Now by comparison, we can write A equal to n minus B by comparison. So this can be written as A plus B equal to n. This is the proof of this theorem. Now we are going to discuss theorem number 3. In this theorem, the statement is NCR plus NCR minus 1 equal to n plus 1 CR. N plus 1 CR. Now we are going to prove this. Taking LHS, this is NCR plus NCN minus R. This can be written as factorial n by factorial n minus R into factorial R plus, and using this formula we can write this as factorial n by factorial n minus R into factorial n minus R. This is, from this we can take common factorial n by factorial n minus R. So we get factorial 1 by factorial R plus 1 by this is NC1 n minus 1. From here we can take factorial n common. this becomes factorial n minus r into factorial r plus 1 upon there is also some mistake here, there is r. So this becomes n minus r plus 1 factorial r minus 1 factorial. Now from both of these terms we can see that here is n minus r factorial and here is n minus r plus 1 factorial. This value is one more than n minus r. So this is greater than this. We expanded this up to this value, and also factorial r is expanded to this value. Then we get n minus r factorial into r minus 1 factorial plus 1 upon n minus r plus 1 into n minus r factorial into r minus 1 factorial. From these two terms we can take common. What is common? This value and this value. So we get n minus r factorial into r minus 1 factorial out of bracket. Then this becomes 1 by r plus 1 upon n minus r plus 1, because these two terms are taken common. Now we simplify it. Factorial n by n minus r factorial r minus 1 factorial divided by r n minus r plus 1. This is multiplied here and this is multiplied here. N minus r plus 1 plus r is cancelled out. Now it can be written as factorial n by n minus r factorial r minus 1 factorial, and from here we can write n plus 1 by r into n minus r plus 1. Now we can write n plus 1 into n factorial multiplied by n minus r plus 1 into n minus r factorial. This term is written with this and this is written with this, r into r minus 1 factorial. Then this becomes n plus 1 factorial, and this becomes n minus r plus 1 factorial, and this becomes r factorial. This can also be written as we can write 1 with n, then we get n plus 1 factorial by n plus 1 minus r factorial into r factorial, and this is the value of n plus 1 CR, and this is RHS. Hence this theorem is proved. Now there are exercise left on this topic. We will discuss the exercise in the next video. For today it's enough. Okay students, thank you.